So up until now, we've been dealing with just right triangles because our SOHCAHTOA Pythagorean theorem only works with right triangles. But let's face the reality of triangles. We don't always deal with just right triangles. So how can I find missing sides and angles of any triangle? And that's where these law of sines and cosines come in. So what we want to do is we want to look at any old triangle, doesn't have to be a right triangle. And what I want you to see is we're going to be talking about angles and their opposite sides. So opposite of angle A is going to be side A. Okay, opposite of angle B, we're going to call that B over here. And then opposite of C, we're going to call this side length C. And maybe to make it clearer, let me color code the angles too. Okay, so what I want you to again see is the relationship between angles and its opposite sides. So that's angle A across from side A, angle B across from side B, angle C across from side C. And we're going to first talk about our law of sines. And what it does is it just creates a proportion. So let's write this down. So this law of sines tells us the sine of angle A over the length of A equals the sine of angle B over the length of B, which is equal to sine C of angle C over the length C. So we can use that to find measures of angles or sides in any triangle depending on the information given. So in general with law of sines, you're going to need a couple angles or couple sides in a certain formation. We'll talk about that in a little bit. All right, so let's go ahead and look at example 1, and I want to find FG. So I want to find that length. Okay, so what I can do is I can take a look at the triangle and say, well, it's not a right triangle, so I can't do SOHCAHTOA, but I can use the law of sines because this FG over here, it has an angle 32 with it, so I can do sine 32 over FG, right? And make that equal to a ratio of another angle and side. So take a look at another pairing. So I've got angle F. And what is the side opposite angle F? Well, that's the 40, right? So I can say sine 40 over, or sorry, sine 39, excuse me, sine 39 over 40. All right, so then I can create a proportion so I can cross multiply to solve. And again, I was able to do that because I had two pairs of opposite angles and sides. So let's go ahead and cross multiply. So I'm going to get 40 sine 32 is equal to FG times sine 39, put that in parentheses. And then I want to get FG by itself, so I'm going to divide by sine 39. And FG will equal whatever 40 times sine 32 is divided by sine 39. There's your exact answer, and I want to round to the nearest tenth. So go ahead and throw that into your calculator and see if you get about 33.7. Again, try to do your exact answer first because I want to see what's going into your calculator before you put it in your calculator. Okay? Take a look at part B. Now I want to find the measure of angle Q. And once again, how do you know when you can use a law of sines? It's when you've got opposite information, meaning you've got a pair of opposite sides and, sorry, two pairs of opposite sides and angles. One thing I forgot to put onto your printout, so you guys want to add this in yourself, PR should actually be 6. So we're going to pretend this was already in or on our papers. All right, so PR should be 6. So what you want to see is, do you have a pair of opposite sides and angles? So I've got a 57. And opposite 57 is 8. Awesome. That's what I mean by one pair of opposite sides. We want to see, do we have another pair? Well, remember, I'm looking for angle Q. So angle Q is an angle I'm focusing on, okay? And opposite angle Q is that 6. So awesome. I do have two pairs of opposite sides and angles. So now I can go ahead and be confident I can set up law of sines. So I can say sine of 57 over 8 is equal to sine Q over 6. So it doesn't matter if you're looking for sides or angles, you still want to set it up in this way. Go ahead and cross multiply now. So I'm going to get 6 sine 57 equals 8 times sine q. And I'm going to go ahead and divide by 8 because I want to solve for q. So I get 6 times sine 57 over 8 equals the sine of q. Remember, how do you get rid of the sine but keep q on the side? Well, remember that's where the inverse function comes in. So the measure of angle q is equal to the inverse sine of 6 times sine 57 over 8. And then you can throw that into your calculator. All right, let's go ahead and round to the nearest degree. So the measure of angle q is approximately, what, 36 degrees? Yeah. All right. So don't be freaked out when you see this huge thing. Again, just put it into your calculator one at a time. So you can do 6 times sine 57, divide that by 8, and then take the inverse sine of that. Or if your calculator can handle it all in one line, just put it all in one line, keeping track of your parentheses. All right, let's move on and consider this triangle here. Based off what we know with regular SOHCAHTOA and law of sines, can I find XZ? Right, this one right over here. Right, it's opposite that 110. But look, wait, I need another pair. I don't have another angle to go with one of these two sides. So right now, no, I can't. So I can't do this, not with law of sines. Right, and it's not a right triangle, so I can't use SOHCAHTOA. That's where law of cosines comes in. So once again, we want to think about the opposite side and opposite angle relationships. So remember the pairs angle A and little a, angle B and little b here, and angle C and little c. Here's the law of cosines. So you take one leg, so we can say a squared, okay? That is going to equal b squared plus c squared minus 2 times b times c times cosine of A. I know that looks like a lot, but this is definitely something you can put onto your note card. So once again, you can do this for every side. So I can say b squared is equal to a squared plus c squared minus 2 times a times c times cosine b. So hopefully you're seeing we open and close with that opposite angle pair, and in between is always the format, add the square of the two legs minus 2 times each leg times that cosine. So finally, this one's going to be c squared equals a squared plus b squared minus 2ab times cosine C. All right. So again, just a format you're going to want to remember, and we'll just see how to work with it. So now let's go back to that triangle we looked at earlier, and let's find XZ using our law of cosines. So what I do is I would identify your opposite pair first, meaning take a look at what you're looking for. So I'm looking for XZ right here. I'm highlighting in yellow, and it should go with an opposite angle, and that's that 110, right? So that's that opposite pair I was talking about. So what I like to do with that is I like to start my law of cosine. So I know I start with the side, so that's xz squared. That's going to equal a whole bunch of stuff, and in the end, times cosine of 110. So I'm going to start and finish with that opposite angle pair. How do I fill out the middle? Well, the other two legs, I'm going to square them. So 35 squared plus 30 squared. That order doesn't matter, right? And then I'm going to take away 2 times each of those numbers and then put that right up next to the cosine 110. And that is the law of cosines. All right, and again, this just takes practice and you'll be able to work through it. Okay, so let's go ahead and finish this off. So that means xz squared. Let me make that a little better. So xz squared is equal to 1,225 plus 900 minus 2,100 times cosine 110, right? And I can keep going and simplifying these numbers. So xz squared is equal to 2,125 minus 2,100 times cosine 110. Remember your order of operations, your PEMDAS or your GEMDAS. Don't subtract these. You've got to multiply 2,100 by cosine 110 first before you subtract. So what I would do here is I would go ahead and now do my square root. Because we're only looking at positive values, I'm not doing the plus or minus here. So I'm going to get xc is equal to the square root of 2,125 minus 2,100 times cosine 110. And this is what's going into my calculator. All right, and again, if your calculator can do it all at once, great. If it can't, do it one step at a time using your PEMDAS. Do cosine 110 times negative 2,100 plus 2,125, and then square root that whole thing, and let's round that to the nearest tenth to get approximately 53.3. All right, and that's law of cosines. Let's do one more, and then we'll be practicing this in class tomorrow. So remember, you can use this to find either angles or sides. It doesn't matter because we're going to end up using either regular sine, cosine, or tangent or the inverse function. So once again, I like to look at the opposite pair relationship. So I'm trying to find angle T. What is the side opposite of angle T? So see, angle T is right here. Opposite of that is the 7. So let's think about how we're going to set up the law of cosines here. All right, remember, I always suggest you can start with your side and the opposite angle. So I'm going to start and finish with that. And then fill in the rest using that pattern. So I'm going to take each of the other two legs, so 13, and square it, 11, square it, and then subtract 2 times those two legs. And then that all butts up next to cosine t. All right, so that's how I'd set up law of cosines here. So this is going to end up giving me 49 equals 169 plus 121 minus 286 times cosine t, right? And then just keep going, simplify as much as you can. So I can add these two numbers together to get 290 minus 286 times cosine t. Remember your order of operations again, don't subtract here. That's a very common algebraic mistake, but it's PEMDAS. You got to multiply before you can subtract. So let's start doing our inverse operation. So subtract the 290 from both sides, and that'll give me negative 241 equals negative 286 times cosine t. Divide by that negative 286 to both sides. That's going to give me positive 241 over 286. That equals cosine t. And remember, how do I move that cosine to the other side without moving t with it? That's right, do your inverse function. So a measure of angle t is equal to the inverse cosine of 241 over 286. And now, calculator, right? So then we're going to get the measure of angle t is approximately 33 degrees, rounding to the nearest degree. All right. So law of sines, law of cosines. You want to know which one is which and when to use the appropriate one. Typically, if you're seeing all three sides, that's law of cosines, right? So if you're given three sides, that's going to be law of cosines. If you're given that kind of side angle side information, that's going to be law of cosines. What do I mean by side angle side? Go up and look at A. That's what I mean by side angle side. Okay. Notice anything else will be law of sines. So remember, if you have two pairs of opposite angle and sides, then it's law of sines. All right, so that's in general what you would be doing and looking for that. You can always, when in doubt, set up both of them and see which one actually works. Okay, we'll practice this in class. Thanks for listening.